Okay, today we're going to be looking at the volume and the surface area of cones and spheres. So let's have a look at some different types of cones and also pyramids. So here we have a square-based pyramid, and here we have a triangular pyramid or a tetrahedron. Now you've got the base, which on the square-based pyramid is a square, on the triangular pyramid is a triangle, and you've got lines that radiate up from the corners of the base and they meet at a peak, and we call that peak the apex. Now you can make a pyramid with a base from any polygon in theory, but these are the two most common. And we can think of a cone as a special example of a pyramid with a circular base. Now cones are really quite interesting. Let's redraw our cone. We're not going to be a very good cone because I'm not great at drawing. If you see this cone, cones have an interesting property. If we were to put this cone inside a cylinder, so the apex of the cone hits the top of the cylinder and the base of our cone is the base of the cylinder, the cone fills exactly 1/3 of the cylinder's volume. So the volume of a cone is 1/3 pi r squared h, where r is the radius of the cylinder or the radius of the base of the cone, and h would be the height of the bottom of the cone to its apex, or the height of this imaginary cylinder that we've put our cone inside. So this is the volume of a cone. Oh, I've put half, it's not half, it's a third, sorry, that's really important. It's 1/3. And this is an equation you need to memorise. So let's look at an example. So find the volume of this cone. So we're going to have our base and our pointy bit, apex, and the radius is 5 centimeters, and the height is 7 centimeters. And we note that the units are the same, so we know that's important. So the volume is going to be 1/3 pi r squared h. So 1/3 times pi times 5 squared times 7. Plug that into your calculator, and to 3 significant figures it's going to be 183 centimeters cubed. Now let's consider a sphere. Now we're just going to be given this volume of a sphere. The volume of a sphere is 4/3 pi r cubed. And again, to memorise this formula, so it's the 4/3. It's the tricky thing with these formula is to remember what the fraction is at the beginning. So for the sphere it's 4/3. So let's do an example. A ball has diameter 6 millimeters. Find its volume. So if the diameter is 6 millimeters, that implies the radius will be 3 millimeters. So the volume, 4/3 pi r cubed, 4/3 times pi times r cubed, 3 cubed. Plugging all that into our calculator, we'll find it's 113 millimeters cubed to 3 significant figures. Let's think of something. Let's now think of the surface areas. So I'm going to draw a sphere. Do we kind of circle in the middle to indicate this is a sphere, not just a circle. We have radius r, and we'll draw another cone with height h and radius r, and this length here is L. This length L is the slant length or height. So the area of our sphere is 4 pi r squared, so that's the surface area. And the curved, so this is just the curved area, surface area is pi r L. Now if you wanted to find the full surface area of a cone that had like a solid base, you would have to add in the area of the circle as well, because this is just, if you imagine taking a piece of paper, making a paper cone, it's just that curved area there, not the circle included at the bottom. So let's do a couple of examples. Find the total surface area of these shapes, giving your answers exactly in terms of pi. Now remember, we did this in the last lesson where you don't calculate the pi in the answer, you leave pi as part of the answer. So here's our sphere we're going to work with, and it's going to have 5 centimeters, and our cone (10 centimeters), and its height is 12 centimeters. So for the sphere, we've got r equals 5, so v equals 4 pi r squared, so it's 4 times pi times 5 squared, so that's going to be 25 times 4, which is 100 pi centimeters squared. Now for the cone. Now remember, the volume for the cone was pi r L. We've not been given L, but what we can do is, if you imagine here, I'm actually going to change the colour of this to make it clear what we're doing. This colour. So imagine, here's the radius of our circle, and here's the height of our cone. And here is our slant length that we need, which is L. Inside here we've made a right angled triangle. See? I'll draw that in bold. And I'll draw it out here to make it clear. Here's L, the height is 12, and the distance from the middle to the outer part is going to be the same as the radius, which is half of the diameter, which is 5. Go back to the writing colour. So we know R, right, R equals 5. We can now use Pythagoras' theorem to find L. We know that L squared equals R squared plus H squared, which is 25 plus 144, which equals 169. So taking the square root, L is going to be 13 centimetres. And this is quite a common way where you might find Pythagoras' theorem being hidden inside another sum, and you're not told to use Pythagoras. If you see if you can see right-angled triangle and you need to find a length that you don't know, think Pythagoras. You often see Pythagoras hidden in trigonometry questions as well. So the cone, I've written V, it's A. Dearie me. So the surface area of the cone A is pi RL, pi times 5 times, times L, which we've just worked out is 13, and so 5 times 13 is 65 pi centimetres squared. And if we want to find the circular base, so the base is just a circle, so it's the base area is pi r squared. So that's going to be pi times 5 squared is 25, so it's 25 pi centimetres squared. And then the total surface area of the cone is 25 pi plus 65 pi, which is 90 pi centimetres squared. So hope that helps.